introduced by one region to another region. Okay, gentlemen, maybe you belongs to a different country and region. I will introduce them one by one. Okay, so the first one, GMV6 Asia Pacific. You can see here is the basic module from 8 HP to 16 HP. This is basic. And for the combination modularization, the maximum you can get is 96 HP. 4 kilowatts is 680 kilowatts. Okay, and for the working temperature range is from minus 15 to 52 Celsius. For heating is minus 30 to 24 Celsius. But for this one, the minimum operating range is conditional. It is conditional. That means it must be customized. So if you have this kind of requirements, you can contact your corresponding sales for more information about this. Okay. And for the other, like the appearance, this is the single fan and single compressor. This is double fan and double compressor. And this is combination. And for the modularization, the maximum can be 4, as opposed to 4 units can be combined together. Okay. And for the other core features, for this part, I will introduce them later.
와 company registration वाली है पुनः बाय online नहीं है तो अच्छा बच्ची है तो online copy đi của nó copy mà okay. Điều này. Hả? Thế này rồi. Được rồi. Đó là big. Speaker on the load. Mute.
Oh, 我知道。 Sorry. Sorry about the microphone is muted. It's muted. Sorry about that. So I will restart the presentation. Sorry about that. Okay, for the GMV6 Asia Pacific, the basic is 22.4 to 68 kilowatt. This is the basic. And for the combination, it can be at most 680 kilowatt. That's the maximum. For the operating range is from -15 to 52 Celsius. That's for cooling. For heating is -30 to 24 Celsius. This is GMV6. And for the GMV6 EU, basic capacity from 22.3 and maximum basic is 61.5 kilowatt. Okay, and if combined, also at most 4 units can be combined, so you can get this. That's the maximum. And for the operating range is from -15 to 55 Celsius. For heating is -30 to 24 Celsius. Okay, that's for the GMV6 EU market. And for next one is GMV6 Middle East. GMV6 Middle East. You can see for GMV6 Middle East, the capacity is also from 22.4 kilowatts, and maximum is 61.5 kilowatts. This is a basic module. If combined, at most 4. Okay. For the cooling range, -15 to 55. For heating is -30 to 24. But you can see in this slide, you can see the difference, the appearance difference. For this GMV6 Middle East, you can see here the color fin. The color of the fin is different, is black. That's we take some anti treatment for the GMV6 Middle East series, and the lifespan of this series in the Middle East region will be longer and the performance will be better. Okay, that's the GMV6 Middle East. Next one is the GMV6 EU market anti-corrosion series. And you can see the basic capacity is the same. The combination is also the same. But the fin color is also black. This is also anti-corrosive painting on the fin. And for the operating range, also from -15 to 55. For heating is -30 to 24 Celsius. Okay, next one is the Latin America. Because of this time, the training is not intended for Latin America, so I will skip these two series. Okay. So for the summary of GMV6 all series, you can see the conclusion of different series. First one is the nomenclature. Nomenclature here. For the GX, this is GX, that's GMV6 Asia Pacific, HX EU T1, GXS, that's Middle East, H1X, that's Europe, EU, inclusion, and this is 2 for Latin America, and also the power supply. For the Asia Pacific, EU, and Middle East, it's three-phase power supply.
Hello, Mr. Now we can hear you.
Okay, sorry. Because somebody just mute my microphone. Okay, it will not happen again. Apologize for that. Okay, let's go back to this slide. The summary of GMV6 World Series. The first difference is the nomenclature. For different region, the letter of them is different. You can see the difference here, and also the power supply. For the GMV6 Asia Pacific, EUT1 Middle East, and EU anti-corrosion series, they are 3-phase power supply, 50 and 60 Hertz power supply. For Latin America, just 60 Hertz. And a certificate, they have the corresponding certificates for the local requirement. And for the applicable region, the first one, Asia Pacific, is for the Asia Pacific, Latin America, and Africa. And for the second one is for Europe. And for this GMV6 Middle East is for the Middle East region. And UAE and the other T3 region, T3, this is a T3 region. And for this one is also Europe. Okay, and this is for Latin America. Okay, now we have a look about the capacity range. You can see for all of the different series, the GMV6 Asia Pacific, the basic module can be max. The basic module can be max because it can reach 268 kilowatts. Okay, but the other series just 61.5 kilowatts. This one, and this one. Okay, that's the difference. And also the operation range for Asia Pacific, the cooling operation range is just 52 Celsius. But for the others 3 is 55 Celsius. That's the maximum. Okay, so now you can see from this slide, for different country and region, the GMV6 most of a part they are very similar. Just power supply, certificate, and the capacity range is different. Also, the operation range is different. Okay, that's the conclusion for a different region. Okay, so let's go to the next part. Is about the core selling points of GMV6. Why we promote GMV6? Why the customer they would like to choose GMV6? Because for this 6th generation VIF is really good. Is really good. So for the performance, the first one, excellent performance. Okay, now we look at this slide. In the GMV6 generation VIF, we upgrade the compressor. We upgraded the compressor, and now it is the EVI scroll compressor. It has the vapor injection, and now you can see the structure, the cross section of the EVI. Now here is the suction. So when the gas refrigerant sucked from the compressor here and discharge, depends on the operating parameter and some environment, the unit will start the vapor injection to improve the performance of a unit. Okay, so the first one, EVI, there's a very big difference with the other ordinary compressor. It will now, let's look at this graph. You can see here with the EVI feature, the unit can save the power, consumption, and also get very good compression. So that means you get more cooling or heating performance, and however, the power consumption is less. The power consumption of the compressor is less than the ordinary compressor. That's the advantage of the EVI compressor. And second one is the pressure relief valve. This relief valve is the built-in pressure relief valve in the compressor here. So if the load is partial load, this relief valve will be opened automatically to improve the refrigerant circulation and just make sure it can satisfy the unit's output. Okay, that's the second one. The third one is about the vortex. The vortex 9. We use this new compressor, and this is the built-in advantage of this compressor. Another one is the internal oil circulation. You can see here there's a oil circulating pipe in the compressor. So if too much oil or too less oil, this pipe will return or discharge the oil to circulate in the system and make sure the lubricating of the compressor is good. And next one is the dynamic oil balance. Here is another oil balance pipe. Okay, and for the rotation speed of the compressor, it can be 140 RPM. So here should be hertz. 140. And next one is the oil pump filter. At the bottom, there is a filter to clean the impurity and some foreign things in the system. Okay. And the next one is the gear pump. Here is a pump at the bottom to circulate, to pump the oil out of the compressor. And next one, let's have a look about the expansion valve. For the GMV6, there are many different expansion valve. So the first one here, you can see this is the economizer expansion valve. It is 480 pounds. And for every compressor, there is a EVI, enthalpy injection valve. So this is another expansion valve, but for this expansion valve, it's just the 5 pounds. So depends on the node and control of the main board. The units will adjust the opening of the column expansion valve or the enthalpy expansion valve. That means we can get 2,400 step precise adjustment because of these two expansion valves. Now we can. What is the advantage of this expansion valve? These two expansion valves. So for the single, if just a single expansion valve, you can see every time and the opening adjustment. You can see every stage. There may be 10 pulse or 20 pulse. You can see the stage, the height of each stage is very high. Because for the precision for just the one expansion valve is not really precise. However, if there are two dual expansion valve, you can see the adjustment of this valve is more smooth. That means the control will be more precise for the unit output. Okay. Okay, now you can see here for if just a single expansion valve, if there are two compressor, for every compressor, the enthalpy increase, they are different. Just only one expansion valve cannot do that. So if there are two, the compressor 1 and compressor 2, they can get the same enthalpy increase because of they can be controlled independently. Okay, that's the advantage of dual expansion valve. Let's go to the next slide. And for the auto units, now we have a look of this picture. Okay, this is a subcooling expansion valve. We already see it, 480 pounds. But for the heating expansion valve, that's a big change for the GMV6. You know, in the previous generation, the heating expansion valve is just 480 pounds. But now we change a bigger expansion valve to improve the diameter of the valve, so that when the units runs in heating, the circulation of the refrigerant will be better. That's the 3000 pounds expansion valve. Okay. For the indoor units, expansion valve also 480 pounds. Next one is about the heat exchanger. Okay, first one is about a fin. Now let's have a look about here. For the others, you can see these two, maybe not very clear, but I can tell you that the GMV6, the tube diameter is smaller than the others brand or the previous GMV5, because now we use the 5.7. We use the 5.7 copper tube, so that the efficiency of the heat exchange will be higher, because the smaller diameter, the better heat exchange performance. Okay, another difference is about the fin design. For the others, it uses the slit. It uses slit fin, fellatrated fin. And for this fin, that's good. But you know, for some region, if there is frost, it may cause the hardness to defrost. So we change the GMV6 to the corrugated hydronic design. That means for the defrosting, the GMV6 here on the fin, and the defrosting will be better, and also hydrophilic design. That's also for the water to drop down from the fin to the chassis. And for the structure, the design structure of the heat exchanger is also changed. For GMV5, that's a total one piece heat exchanger. For GMV6, we separate the condenser to two different separated part, independent part, up part and lower part, and they use two independent capillary to distribute the refrigerant. So let's have a look here. For the GMV5, there is one inlet and one outlet for the auto unit heat exchanger. And for GMV6, there is one inlet, but we separate the two distribution to the up part of the heat exchanger and the lower part to get a better heat exchange with the ventilation. Because you know, for the auto units, the up part and the lower part, the the wind field, they are different. If just one piece of the condenser, that's not the best choice. And if you separate to two parts, every part they can get a bad heat exchange. So, for example, if lower there are more air supply, that means we can distribute more refrigerant to this region that can get a sufficient heat exchange. And also this part, we can separate to distribute the refrigerant to the up part and lower part. That's beneficial to the heat exchange. Next one is about the ventilator, the fan. The first difference is about the fan motor. You can see here the fan motor's appearance, design, that's different. We use the reversed S-shaped tail. Why we use the reversed S-shaped tail design? Because for this kind of design, it will reduce the, reduce the turbulence of the tail. Reduce the turbulence on the tail of the motor. So that means the noise will be lower. The noise will be lower. Accordingly, the volume, air volume of the ventilation, it will be higher, will be better. Okay, that's why we use the reversed S-shaped tail. Okay, that's a fan motor advantage. Another one is a structure about the air grill here. We use the flat grill, and for this area, you can see the air supply area can up by 7.8%. That means even the same speed of the air, but you have a larger air output area. That means the air volume for GMV6 is higher, about 16%. About 16%. Okay, next one. We talk about the energy saving function. For the GMV6, this function is the same with the previous GMV5. Both of them, they have the energy saving function. And for the auto unit running, there are three different choices. The first one is the capacity first. That means don't consider the noise, don't consider any limitation, don't consider anything, just maximize your output, maximize your capacity. Okay, another one, that's auto energy saving. For this energy saving, it can balance the capacity and the power consumption. Balance capacity and power consumption depends on the running state. So the maximum you can get around 15 energy saving %. Next one is the forcible energy saving. That means if you set this energy saving, the unit will limit the frequency of the fan and the compressor to reduce the power consumption. And maximum you can get 20% reduce about the power consumption. Okay, that's the energy saving function. But just remember that no matter you choose the auto energy saving or forcible energy saving, if you choose the energy saving, absolutely the capacity will be affected. About 10 to 20%. About 10 to 20%. Okay, and you can choose the setting according to your demand. Next one is about HVAC control. So some people may be curious about what is HVAC. it's a new jargon, right? It's a new jargon for the VIF. So here, HPLC actually is logic is a control logic for GMV6, and it stands for high performance alternate control. So what is the HPLC, high performance alternate control? Okay, let's look here. Let's look here. For the conventional unit, you know, the units running is shifted, depends on the time. So maybe this unit will run for time. Next a few hours will be another one, and next will be another. There it's in sequence. For conventional control, is in sequence to change the running and standby to balance their running time. But you know, for the VIF, there is a characteristic for the VIF. You know, for the VIF, there is excellent efficient region. It's not the minimum capacity output, not the maximum capacity output. It's in the middle, right? It's in the middle, about 60 or 70% output. That's the optimum. That's the optimum efficiency region for the VIF units. So if the VIF unit has this kind of characteristic, why we don't just use this to improve the VIF performance and reduce the power consumption? So that's why we develop the HPLC. For example, in part load, if the unit's in part load, that means we can choose different basic module and combine them to output just in the middle capacity region. Not the maximum one, not the minimum one. We just choose the best of the two, depends on the cooling node or heating node of the indoor, and make sure these two units, the output capacity is in this range. So that's the optimum, right? That's the optimum choice. Okay, so that's the optimum matching between the indoor units load, indoor unit node, and outdoor units capacity, and make sure the units can run in this excellent efficient region. And this is the best output point for the VIF unit. Okay, that's the HPLC. Next one is another technology about control, SRL. SRL is the self-reaction node control logic. So what is SRL? We just have a look about this graph. For example, in cooling mode, this is your setting temperature, right? The blue line is your setting temperature, and this is the actual indoor temperature. This is the detecting temperature by your sensor. So with the longer running time, the actual indoor temperature will be close to your setting. That's right? Will be close to your setting, and in this case, the unit should be standby, right? Should be standby or shut down. Because the setting temperature is reached. Okay, that's the principle. That's a principle of a unit. Okay, now we have look about here. For the general no pressure change is very flat. Only when the actual temperature reach the setting temperature, the unit just shut down and make the indoor units standby. Okay, and you can see before the reaching points, the control of the general no pressure change is very flat, because the units, they don't know how much distance I will reach to the setting point, right? But for the SRL no pressure change, these units will detecting the pressure and the temperature. If the actual indoor temperature is very close to the setting temperature, the units will change the pressure, will change the low pressure slope. You can see the slope gradient. The more close to the reaching point, the slope will be bigger. That means, you know, the more close, the more higher no pressure. The more higher no pressure, that will reduce the output and reduce the how is that? Reduce the power consumption. Maybe these two looks very similar, but SRL, this control logic, make it more smart, make units run more smart, because the slope, the pressure, the low pressure change slope is more sharp, more responsive than the general. Okay, and for the power change is the similar. If the no pressure increase, the power consumption will be reduced. So in general, SRL, this control logic, the first advantage is about the comfort. That's better for the comfort. Another one is the energy saving. Okay, that's for cooling mode. And for the heating mode is similar. For cooling mode, we SR control the no pressure. For the heating mode, it control the high pressure. Also depends on the actual and the setting temperature. The more close to the reaching point, the slope will be bigger to reduce the power consumption. Okay, that's the SRL control logic. Next one is about the refrigerant circuit control. For VIF, okay, not only VIF, almost all of the air conditioner, there is a phenomenon. It's a no temperature refrigerant transfer, right? If the unit doesn't run for a long time, lots of refrigerants will be stored in the compressor, because the location, the temperature here, and the temperature difference here and the ambient, it will cause the refrigerant to transfer from the other hot location to this cold location. So the longer time, after long time standby, here will be a lot of liquid storage here. And for the GMV6, we can judge the gas liquid separator if there is too much liquid refrigerant inside, according to the system parameters such as the pressure. Okay, here the no pressure and the high pressure, temperature and the speed. If the suction and inlet, gas liquid there is inlet and suction. If according to the difference of here and also the pressure difference. So and in heating, we can even supply some gas to the separator. Make the liquid evaporate and circulates faster. So that's when the heating capacity, the capacity during the startup process is increased about 15%, because we can distribute some hot gas to the liquid gas separator to make it evaporate and circulate faster to get a quick start in the heating mode. Okay, that's the intelligent refrigerant circuit control. Next one is about the defrost. The defrost is a common problem for air conditioner in heating mode during the winter. The other units, there will accumulate a lot of ice. So the units have to do the defrosting logic to eliminate the frost. And for the older units, the defrost depends on the time, on the running time. It's fixed. How long time running, and then start the defrost. So it's fixed. It's very stupid. It's very stupid. And then the common units, it will detect some parameter such as the temperature and pressure. Okay, that's the common units. And based on that, based on the temperature and the pressure, now the GMV6 not only consider the temperature and the system pressure, it will also consider the workload rate. The running, how many indoor units are running in this case. So it will consider workload rate, also the pressure and the temperature, and also consider the defrosting capacity. So for GMV6, not only temperature and pressure, it will also consider the running rate of the indoor unit at this moment. So the unit will allocate the best defrosting time, and that will not affect the other unit. Okay, that's the best choice. Do the defrosting and not affect the other running units in heating mode. So the unit will judge what is the best timing, for defrosting logic to start. Okay, that's the intelligent defrosting for GMV6. And for the defrosting, I already introduced. The unit can change the capacity, depends on the real-time parameter such as pressure and the compressor temperature. And another one is for GMV6, you can also choose the heat storage box. This one, heat storage box. If in heating mode, when the units start defrosting, the units can absorb the heat storage in this box to do the defrosting, and it will not affect the other regular indoor units running. Okay, that's the heat storage box. That's a lot of choice. And for the noise control, this fan motor I already introduced. The S-shaped tail design, it will reduce the turbulence here, so the noise will be lower. Another one is the grill. you know, the structure of the grill is sunk, immersed. The structure is flat here. So most of the noise will be, how is that? Will be circulated, will be isolated in the middle, in this region. So this kinds of structure to reduce the running noise, okay, of auto units. Another noise control is about the compressor, right? For the compressor, there are two solutions. First one is sound absorber, the material. We use some sound absorption material to cover the compressor. Another one is metal. It's a metal soundproof enclosure. It's a metal. It's a case. It's a box. Looks like a box to cover the compressor 100%. Just isolate the compressor noise. Okay. For this one, only the single compressor unit has this one, because for the single compressor units, the space on the chassis, that's more wider. So it can use this sound absorber. A lot of noise resource is from the refrigerant circulation. So we use a Liu type silencer to reduce its pulsation. It's a pulsation reduce silencer. Okay, to reduce the refrigerant flow noise. That's the noise control. Despite that, a lot of noise is about the refrigerant flow in the corbel pipe. Now we have a look about the refrigerant status in the corbel pipe. So for the general control, there are two ways: the liquid and gas mixture flow in the corbel pipe. You know, the mixture, it will cause very it will cause very clear noise. But if there is a total liquid in the corbel pipe, so you can just consider your water pipe in your home. This is very quiet, right? Because just the water, all of them is liquid, so the noise will be very lower. And according to this principle, we adopt the subcooling. The first one is the subcooling. It can get about minus 35 Celsius subcooling. So the units can make sure when the refrigerant flow in the corbel pipe is 100%, is totally liquid in the corbel pipe. Okay, and also here expansion valve to control the throttling before the indoor unit. Silent throttling of every indoor unit. Another one is the gas separator, and for here, the gas separator volume is very big. So here it can store most of the refrigerant here. Next one is intelligent crowd control. Okay, for this is the kinds of control logic. So first, look here. The units can learn and remember. It can remember the user's habit, such as today, how long time you turn on the VIF. when did you start? When did you turn off? The unit will remember the period and the timing for the unit running. And for different day, for different day, you know, for most of us, we are just a staff in the company. So actually, our lifestyle that's very how to say that there is a rule, right? There is a rule that's very that's a circle, right? That's a circle, and according to our lifestyle, the unit can remember our habits. And for example, during the daytime, such as 8 a.m., right, to the 8 a.m. to 6 p.m. That's our working time. That's our working time in your office. So in this time, the air conditioner must be very very strong, right? The setting temperature will be very low because lots of people stay in the room. So in this period, that's normal output. And after working time, you go back to your home or sleep. In this period, the units will know this time, this period, that's a larger user's habit. So in this case, it will reduce the output, and accordingly the noise will be reduced. Okay, that's the night time. Just consider this is night time. And the next day, there's a larger working day, and the units remember, okay, now it's time to speed up to maximize my output. So it will restore the normal output. Okay, and this is automatic control, automatic quiet control by the GMV6. It can learn your habits and define your habits and remember your habits and run as your habits, run as your air conditioning habits, and do the right thing in the right time. That's the GMV6 noise control, intelligent quiet control technology. Okay. And the noise can be reduced by 3 decibel, about 3 decibel by this control logic. Next one is about the hello friends. Our training is almost 1 hour. Do you need a break? Do you need a break or just continue the training? And everyone, you can just answer or input input in the chatting box. Do you need a break or just continue? No response. Okay. Okay, maybe we just continue our training, right? Continue. Okay, we just continue. Okay, next one is about intelligent control and management. The previous part is about the system, the VRL system advantage. Now we go to another part. I'll go to another part. It's about the control. For the VIF units, you know, the project is very big, right? It's very big, maybe thousands of Indo units you install in the building. And a lot of customers, they are very careful about how can I achieve a really convenience control for the VIF system. So in this chapter, I will introduce different control method for the VIF units. The first one, let's have a general overview of the intelligent control. Okay, so that's the overview of GMV6. For GMV6, for example, you install here. Actually, in China markets, we can realize the cloud server, but unfortunately in the overseas markets, due to the local government policy or some restriction, so maybe we cannot. But if you want, you can contact your sales to ask about this kind of information. That's a cloud. And despite that, you can use the central controller and also some the other software, the wired solution, right? The wired solution or wireless solution. For the wired solution, that's absolutely for most of the markets, wireless solution. That's absolutely okay. But for wireless solution, because of the transmitting of the data, may be restricted by the policy for the wireless solution. So please ask your sales for the wireless solution. Okay. So for the wireless monitoring, the first one, wireless monitoring system. Here, this is our monitoring software. Through this software, you can monitor the running of GMV6 on your computer, And for this monitoring system, it can realize a very large scale group control. The system can be up to 8,160 indoor units. That's the maximum for just one set software. So you know the expansibility of this monitoring system is very good. I think currently maybe no project can exceed the limits. Maybe. Okay, so the expansibility is very good, and also the responsive, because we accept for the laptops you need gateway and cable connect with the VIF. So you know the control precision is about millisecond. And next one is the distributed networking. You can get the LAN network or WAN network. Depends on your design. And for the model, for the unit model, not only VIF, also the rooftop, UMatch, hot water, and air duct, large air duct. All of these units, they can use the wireless monitoring software. Okay, that's the first solution. And if we see the detail, if we have a look about detail, now you can see this is the topology network of the intelligent monitoring system. For this system, for this software, first you need a computer, right? You need a computer and a router to plug your cable, and also a controller. This is a gateway, monitoring gateway. And for each gateway connects with router, and then each gateway connects with your VIF masked auto unit. Then all of the system parameter, running parameter, and error, every information can be transmitted to the controller, and the router can collect them and send them to the computer, and finally you can get the display on your laptop. Okay, that's the topology. And so for the system composition, first the computer, right? Absolutely, computer, and monitoring controller here, and the router, and the wires, some cables, some maybe the two cores cable, maybe the network cable. Depends on the section in the topology. Okay, that's the first one, wireless monitoring system by the cable. And another solution is not by the cable, it's by the DTU, the data transmitting units, wireless controller. For this wireless controller, for this one now is very popular. It's very popular in China because in China markets, our GRI have a very good cooperation and relationship with the telecom or Unicom, the carrier, the communication company. So we can cooperate with them to realize the wireless controller control. And in this wireless controller, for the auto units, every auto unit there is a wireless controller built-in, installed on the electric box. And for the data can be transmitted by the base station, and to the server, to your local server, or the server in GRI. And for some projects, maybe it's very remote, and for the cable, it's very hard to do the cable there, so they can use this kind of wireless controller. But for the overseas, okay, gentlemen, for your local market, you have to ask our sales and take your local policy restriction into consideration. Okay. Next one is about the billing system. For VIF projects, there are many indoor units located in different rooms. So for different room, the owner or the customer, when they calculate, when they ask you about the power billing. So for VIF units, how to calculate the power consumption and give the customer a billing about every indoor units, that's a very urgent problem. And for this problem, we develop the intelligent billing system. So through this system, you can get the power information, the power consumption information from gateway and from power meter from our units, and finally get the summary, get the output, get a summary on your display. And in the billing system, there are some advantage. First one is the accurate billing. The billing system, the billing software can calculate the power consumption for each indoor unit, and then it can provide you a detailed billing table, Excel for you. Then you can tell your customer, tell your owner about the power fee. That's the first one. And for the control and the management, that's the one button control. For the billing system, not only for billing calculation, also you can use it as a management platform. You can just control all of the indoor units, just one click, and monitor the fault condition to monitor every indoor unit running. If there is fault, the computer, the display, there will be a warning to remind you and report to you to do the troubleshooting. Okay. Next one is the multimeter capability. Because for different country and markets, the local brands, they are various. Some brands are maybe not available in the local market. And for now, the gray intelligent binning system, it can support 5 types of emitters to satisfy different location, different markets globally. And for the brands of the emitter, you can ask yourselves which one is the best for your local market. Okay. And here is the topology of the intelligent binning system. So first one, you need a computer, right? And a router, and then a gateway. And different with the monitoring software, because for this binning system, you need to get the power information from the VIF unit. So you have to install emitter, that's power meter, a power meter for each system. Okay, and then cables connects with the power meter, link with the power meter, link with the VIF system, and then all of the power information to the gateway, the system, the VIF system running information to the gateway, and then to the computer, and you can get the final answer on your laptop. Okay, so that's the topology for the binning system. Despite that, despite the software, the monitoring software, binning software, you know, for the project currently, there are many building integral solution for one project. So they may ask if there is kind of protocol we can choose for our project. Yes, we have for different protocol. We have the corresponding gateway, backlight, Modbus, and KNX. Okay, this is backlight gateway, and H2M home bus to Modbus gateway. This one, and also the Modbus gateway TCP or RTU. These two, and KNX protocol is very popular because of it's very easy to install, and we also have this KNX, and this is appearance of this different types of gateways. Okay, so it can support multiple model, including the VIF, the UMatch, the rooftop, hot water, and the big duct unit. And for the protocol, Modbus, gateway, KNX, and home bus to Modbus. Okay, and so actually depends on the gateways. You can get a third party. You can get a third party BMS system docking. So you can do the design for your projects by yourself. Okay, by yourself. Okay, next one is about the controller. So for the controller was very popular for the VIF units. How can I use one controller, just control one button to start or shut down all of the indoor units? So you can see here we have two different central controllers. One is this one. This is a small central controller. This is a big size central controller. So actually for the central controller, it can support one system or multiple systems. If you use this one like this, just the one system, if you connect like this, you can control multiple 16 systems. And for the VIF, UMatch, free match, and mini split can be supported for the central controller. For the CAN network, you know, for the central controller, there are different ports different ports for signal input. And for the CAN input, it can support 16 systems and 255 indoor units, one central controller, this one. And for the Modbus network, there's a lot of ports. There's a lot of ports on the central controller. Can support 36 indoor units. Just the one central controller can support. Okay, that's the maximum quantities the units can support. Okay, for this CE52, this is the big size central controller is 7-inch. 7-inch. And for this central controller, it can support all of the VIF and LCAC, night commercial and VIF, and RAC, mini split can be supported for the CE52. And the total, that's the total amount. CAN network and Modbus network, that's the total. And for this one, that's a larger central controller, CE54, but this is the 4.3 inch display, and maximum just 32. Because of this slide, there are too many information. I think we can skip this one. Later, I will show you a table, a brief table for conclusion. Okay. And this is a commissioning tool debugger for the VIF debugging. It has the 4G memory storage inside in the debugging tool, and this is also 4.3-inch colorful display. It can do the debugging. User cable connects with the outdoor units or indoor units. Then you can do the commissioning, parameter checking, and the setting. Everything you can do on the commissioning tool, and even the program upgrade. For GMV6, for GMV6, the chip, the program, the software we put in the chip, it can be upgraded by the commissioning tool. No need to change your new chip. You just use the commissioning tool to upgrade the logic. It's very convenient, right? And also save the data. The data can be saved to the storage, or to your USB. To the storage, and you can use your USB connect with your laptop to export the data and for analysis. Okay. And the other wired controller, this is standard one, XK46 standard one. This is the hotel keycard. It has the keycard. And this is XE70. That's a new wired controller for GMV6. For this one, XD55 is a touch screen. Okay, so let's look at this conclusion table. For the CE52, that's the big size central controller. For the VIF quantity 255, system 16, and the timer, it has the calendar timer, 7-inch display. Okay, for this small central controller is 54 inch, 54. Sorry. CE54. It's the 4.3 inch. Sorry, and for the quantity is 32 VIF indoor units, and the timer is just a waking timer. It's only waking timer. And for the wired controller, XK46, it is the standard wired controller. And for this one, XE70 33, this one it has the waking timer. And here, pay attention to this remark. It has the independent swing for cassette unit. You know, for GMV6, our new model of the cassette indoor unit, it can do the independent swing for swing mover. For swing mover can be independently controlled. And if you want to realize the independent swing, you have to use the XE70, this controller. This is a special controller for the independent swing control. And another one is the ERV with the DX coil. It can also use this XE70, this wire controller. Okay. Next one, XK79. XK79, that's another wire controller. It has the key. It's used for the hotel. It's specialized for the hotel. Has a key card function. You can use the key card in and card out to turn on or off the indoor unit. And also setback function. For setback function, later I will introduce later. And next one is XK55. That's a touch screen. That's a touch screen. Looks like your smartphone touch screen, and has waking timer. It has waking timer. For the wireless controller, this one is a standard wireless controller for GMV6, and this is the debugging wireless controller. That means the after sales person, your engineer, they can use this special debugging wireless controller for the troubleshooting or commissioning. Okay, that's the debugging wireless controller. Okay, that's the second part about the control. Next part is about the clean and fresh air. So for this part, we just have a quick look. So for GMV6, it can connect with the fresh air processing unit. Like this. This is the fresh air unit. And for the cassette, you can choose the, how is that? This part. This optional part. This optional part for the cassette unit. And for the cassette, then it can get about 10% fresh air, because you can see here, this too is the fresh air intake from here, and then supply the fresh air to your room, and this is a cassette solution. And next one is the ERV. For GMV6, can collect with the ERV unit. Linkage control. For GMV6, not only regular indoor units also link with GMV6. When control them, they can be linked. They can be linked together. And this is air box carbon dioxide concentration, or PM2.5 temperature, humidity. Use this one to detect the air quality and parameter in the room. And for the ERV is constant air volume and linkage control with the regular indoor units. And for the air volume is 150 to 500 cubic meter per hour. 5 models running. And this is another one, ERV with the DX coil. You can see here, for the ERV, just the hexagon, right? Just the hexagon, filter and hexagon inside. And for this one, it has a DX coil. So, which means this unit can connect with the copper pipe to get the refrigerant and do the cooling or heating. Okay. And for the ERV and DX coil, this unit, there is a hexagon. There's a hexagon heat exchanger inside, so it can recover the energy from the discharge air and warm up or chill the fresh air from the outside to recover the energy. And also there is a built-in heat exchanger to do the heating or cooling. And for this ERV and DX coil, there is a reminder to remind the customer how long time they can remind the customer to replace or wash the filter by the using period. And this is the specialized XT70 for the ERV and DX coil unit. And for this is constant air volume. Okay, so that means the air supply is constant. Air supply is constant no matter the parameter. The fan motor will automatically adjust the speed to make sure the volume is constant. And for the control, it can be linkage control with the regular indoor unit, or free cooling by the heat exchanger, or group control by the central controller. Okay. And for the other parts about the healthy fresh air is a filter. This filter is optional. You can choose this filter and install to the air return of an indoor unit. Okay, but it should be customized. This is the medium efficiency filter. It can be about 70 to 95%. It's relatively high for the PM2.5. Okay, but if you have this kind of requirements, you have to ask yourselves for the customization. And for this filter, the resistance is small, and the material is flame retardant. No worry about the fire. This is flame retardant. And for the installation, there are 3 directions. You can up, down, left, right, and back for the dismantle. Okay, the last part is about the last feature about the stability and the reliability. Okay, so for this one, it's about some upgrades about GMV6 control and some technology. So first one, this is the anti-corrosive for the Middle East, GMV6 Middle East and GMV6 EU anti-corrosion series. This is only for Middle East GMV6 and the EU anti-corrosive GMV6. And for these 2 series, we take some anti-corrosive treatment, such as the fastener, the screw, and the electric box, and the metal, and the fan grill, the grill here, and gas liquid separator, and the fin of the heat exchanger. We take some special anti-corrosive painting on the surface, so to improve the lifespan. So if your project's in the coastal areas, or the desert, or the Middle East region, or some, the location environment is very extremely corrosive, you'd better choose this series, the Blackfin anti-corrosive series. And for such as, for example, the fastener, you can see the test time. The ordinary screw, the neutral salt spray time is just 120 hours, but for the zinc nickel alloy screws, this new screws is 500 hours neutral salt spray time. So that means the lifespan of this new fastener is longer when you install in the corrosive environment. Okay, that's a fastener. Similarly, the controller, we will also improve the anti-corrosive time, and the metal, and the grill, and the gas liquid separator, and the heat exchanger. Okay, just remember the black fin, and for the Middle East and the EU anti-corrosive series, that's specially designed for the coastal region, Middle East, and some corrosive environment. So if your project is in that location, that's the recommendation. That's the recommendation series. Next one is about the communication technology, CAN protocol. CAN protocol. Okay, for the CAN protocol, I think most of our participants, they already installed GMV5 before, right? You already installed the GMV5. And for GMV6, CAN Plus is very similar with the CAN. But for the GMV CAN Plus, the first one is the load number. That means the indoor units quantity. The maximum can be 100 indoor units for GMV6. But it must be customized. 100 indoor units maximum. It needs to be customized. Okay. And for the communication, the cycle for one system is less than 500 milliseconds, and the response level is milliseconds class. Okay, and for the indoor units quantity is 100. And that's the advantage of CAN Plus. So it's faster. And bigger indoor units installation amount than the previous generation and the other brand. This is also CAN Plus. So in general, 100 indoor units can be installed for the CAN Plus network at 16 systems. Okay, but if more than 80, you have to ask the sales for customization. And next one is the reliable. For VIF, if there is one unit is 40, and for GMV6, it will not be affected. By just one or several indoor units fault. If it's not very heavy problem, it will not be affected. That means the units can keep communication and keep run. A lot of advantage is the addressing. That's automatic addressing for the CAN Plus. No need to do deep switch or setting or anything. You just press the button to net the units, distribute the address by itself, and the interface is now polarity. You can do the opposite match or cross match. Okay, you can just connect the cables as you wish, as you like. No polarity. Okay. And next one is about the enthalpy adding control. That's what I introduced in the previous slides. It's about the EVI, expansion valve. For some brands, they use the solenoid valve for enthalpy adding. If there is a need to use the enthalpy, the solenoid valve open and injects the vapor to the compressor. However, GMV6 uses the expansion valve. That means the control is more flexible and precise. It can gradually increase the enthalpy amount by the demand. So, for example, for the common solenoid valve, if there is a EVI control at the moment, okay, that looks like this. But if some problem, okay, it's shut down. immediately, abruptly, right? Abruptly. So actually, for this is not good for the units running. However, for GMV6, even some change of the compressor demands, it will adjust. It will adjust the opening of the EVI expansion valve to make the control more flexible. Okay. Next one is about the oil system. For VRF units, it needs to do the preheating, right? Lots of people, they are very headache about the preheating. They think the 8 hours is too long for the wait. So in GMV6, we change some design. So for the previous generation, we use the heating belt on the compressor to do the heating, just the one heating belt. So the power maybe not very big. It needs 8 hours to finish the preheating. However, in GMV6, not only in heating belts, the compressor can use the motor winding. You can see here, the compressor can use the winding to generate the heat as a heating belt. It can use the winding 1 gear, 2 gear, 3 gear, depends on the environment. So actually, the preheating waiting time can be shortened to 2 hours. Okay, that's very convenient, right? For especially for your commissioning job. Okay, that's the oil preheating. Next one is the double back heating. Double back heating. So what does it mean? Double back heating. For the ordinary compressor, there is only one preheating belt. Only this one, right? Only this one. If this one is faulty, how can compressor get preheating? But in GMV6, there is a backup. If the heating belt, the external heating belt is abnormal or faulty, the units can use the winding as a backup heating, for the oil. Okay, so that's really good for the reliability about the running for GMV6. Another one is the oil return system. There is 6 major oil paths. First one is the oil return from the oil separator, the red line, the oil return. That's the main oil return. Another one is the low temperature oil return. You can see there is a lot of oil return pipe. If the ambient is very cold, this oil return solenoid valve and capillary will open to get more oil from the oil separator. And in the discharge and suction, there is an oil balancing path here, the number 5 oil balancing. That's a lot of oil path. Next one is the main pipe, the copper pipe. We will know that the copper pipe and gas liquid separator. There is also a oil return path for the compressor. So actually, the unit has a 6 major oil paths for the oil circulation and return. And for the oil return, how the compressor can get oil return. Okay, let's have a look about this comparison. For ordinary oil return, you can see here. For ordinary oil return, the time is, how to say that? The time is, how to say that? For example, here, if run, maybe something happen, the units exits the oil return control, and you can see this area. This is the insufficient oil return time. That means the oil return is not enough for the compressor. Okay, and if something happened to the units, the unit cannot enter oil return control logic. Okay, however, for the GMV6 compressor, it used the differential pressure flow to return the. If the oil is insufficient, this time is not long enough for the oil return, the unit will prolong the oil return time to a longer time. Okay, by the differential pressure. For the discharge and suction, there is a differential pressure, right? So to keep the oil no more a long time, that means you can get oil back to the compressor. And by this control logic, the units can guarantee the lubrication of the compressor by the differential pressure from the high pressure by the pressure force to finish the oil return and circulation. And for GMV6, another good news is it cancels the oil balance pipe. That's really good for your installation. No need to install the oil balance pipe anymore. Okay, because of the technology I introduced previously, the oil balance pipe no need anymore. For the compressor, another control is about the active compressor oil drain control. I already introduced in the compressor there is a pump, right? There is a pump and a pipe inside for the oil discharge. So if too much oil, okay, the question is too less oil, it may cause the lubricating problem. However, if too much oil, is that good? Is that good for the compressor? No, right? No. If too less oil, that will cause the worn of the compressor. But if too much oil inside, it will also cause some problem because oil it will circle the winding, circle the motor, and the oil the insulation of the heat is very good. So if too much oil in the chamber, it will cause the heat dissipation. The heat dissipation of the compressor may be poor. So if too much oil inside, the GMV6 compressor can discharge the oil to the gas liquid separator. To the oil separator, actively. Okay. Next, reliability technology is about the rotation control about the compressor. If there is two compressors, the units can shift the running sequence, running time to balance the compressor running to get a longer lifespan. And HPAC I already introduced. Depends on the indoor unit capacity. The system will choose the optimal match to make the units run in the highest efficiency region. Just still remember about the curve, right? In the middle. That's the HPAC control. Next one is about electric box. The structure is more compact. This is GMV5, this is GMV6. Here the size is smaller, about 35%. When you when you change the components or when you do the service. It's better for your operation. And for the material of the electric box is the aluminum alloy. It's aluminum. All of them is aluminum. All of them is aluminum. Yeah, all of them is aluminum alloy with the very high conductivity. So that's really good for the heat discharge. No worry about the electric parts. No worry about the overheat. No worry about the temperature here, because this is really good for the heat dissipation. And next one is the no temperature running. Okay, for the GMV6, no temperature running. The start time, there is a turbo algorithm control for the heating running in a very cold ambient. And for this turbo algorithm control, at the beginning, the unit will just control the compressor fan and the expansion valve, all of them, to accelerate the output speed. Okay, gentlemen, wait a moment. And the starting time can be shortened by 50%. That it can get a very quick start in heating mode. Okay, next one is about defrosting. For the VIF, the defrosting is a very headache problem in winter, and normally the units will switch to cooling to do the defrosting. However, for GM6, there is a special gas bypass copper pipe at the bottom from the discharge. You can see here this compressor, this is discharge. So this is a special copper pipe stretch to the chassis, the VIF chassis. So in winter, there is a cellular valve here. It will open to distribute some hot gas to eliminate the ice and the frost in the chassis. That's a low temperature anti-freezing control. Okay, for this one, I think we no need to discuss. The operating range I already introduced. For heating -30, for cooling 55, and also different with your local series, depends on your market and country. The last part is about our engineering, design, and installation. Okay, that's the last part. Okay, gentlemen, I think you are very tired about the training. Maybe 10 or 15 minutes we can finish the last part. The first one is the capacity. It's an increase about 9%. Maximum can be up to 90.6 horsepower. That's the maximum combination. Okay, and also the size. The GMV6 is more compact for the floor space. For the single compressor unit, double compressor units, both of them, the size, the diameter, dimension. The dimension is smaller. So that means the space requirements for installation is also smaller. And a lot of good news is for the transportation. You can put this into the elevator directly, and that's good for your transportation and the installation. A lot of improvements is about the air duct, the auto units air duct. For the GMV5, it's just 82 Pascal. For GMV6, it's 110 Pascal. That means you can install a longer discharge duct when you install the auto units in the basement or some closed area. That's good for your construction, And this is fan anti-wind design, especially when you install the discharge ducts to other units. If there is monsoon or heavy wind, it may cause the fan motor of other units running reversely. And for the GMV6, there is circuit. There is circuit connects with the fan motor to detect the rotation direction and the speed. So if the running direction of the fan motor is reverse, the units will stop the fan motor immediately and drive the fan motor to run normally immediately. There is a circuit detection for the fan motor running direction. Next one is the pipelines. So for the indoor units, height difference is 30 meters. And for the indoor units and the outdoor units, height difference is 110. Depends on the location of outdoor units. If indoor units upside, 110. If outdoor units upside, that's 100. And for the other, the maximum single pipe is 200. It's 200 meters. And the equivalent for the maximum equivalent single pipe is 240 meters. And for the total pipe length is 1,000 meters. 1,000 meters. And for the maximum length from the first branch to the farthest indoor unit is 120 meters. And the height drop is 110. For indoor units, 30 meters. Okay, and you can see a lot of specification limits is improved compared with the GMV5. That means your capability, adaptability for the project and the design, that's better for GMV6. And for the indoor units, GMV5 and GMV6, they can be is compatible for GMV6 to use the GMV5 indoor units. The indoor units, they are the same. So that's if you have many stock about GMV5 indoor units, no worry about them. This GMV6 can still use them. And for the installation, the addressing is automatic addressing, and the low oil balance pipe save your cost of the copper pipe. And for the outlets, 5 direction: left, right, up and down, and the back, bottom. And the other compatibility, they are the same with GMV5. Indoor units the same. The debugging almost the same. The controllers they can share the controllers. For debugging now, the GMV6 use the outdoor unit debugging. Press the button to start the debugging, or debugging software, or the commissioning software. That's what I introduced, commissioning software. 3 choice for your debugging, for your commissioning. And for the service and the maintenance, sometimes when maybe you need to recover the refrigerant, you can choose the indoor unit refrigerant recovery from the indoor side to store in the heat exchanger of outdoor units, or you can recover the refrigerant from the 40 outdoor units. That's good for your service and save the refrigerant charging. Next one is the backup operation, such as the module emergency. That's the same with GMV5, and also the compressor emergency running backup and the fan emergency running. Another difference is the GMV6, it has the sensor emergency. That's a new function. For example, if some sensor on the auto units is broken, the units can use a very close location sensor as a backup, such as discharge and top shell. They can be backup, or the tube and ambient, they can be backup. Not the same detecting value, but if they use the backup, the unit there is a correction logic for the parameter. But you know the backup is just the backup, right? Just for emergency. Okay. And for indoor unit emergency, some indoor units offline or a problem, you can disconnect the indoor units from network. No more than 3 indoor units can be removed from system at the same time. Okay, that's good for the total system running. Even you have some indoor units to troubleshoot. Okay, no more than 3 indoor units. That's the emergency for indoor side. And another one is the electric box here. The space is very wide. It's very wide. Even a person can get into to do the operation, such as the brazing or change the components inside. And the indoor unit self-positioning, the VF can use the buzzer of indoor units to help you locate the indoor units and find the corresponding indoor units what you want to solve. Use the buzzer to help you follow the sound, find the unit. Okay, next one is the setback function. This is the special function you can achieve from the XK79. That's a hotel key card controller. What is the setback function? You know, for some hotel, if the customer they go out and the unit's off, and in this case, if no setback function, the room temperature is very hot, especially they go out just for shopping or for sightseeing, and when they go back to the room, it's very hot, and it will take a very long time to cool down to the comfort setting. But if the setback function is on, even the customer they go out, and the setback, there is a limit. The upper limit and the lower limit. If the setback function is activated, the unit will automatically start to keep the room ambient in a relatively comfort range. So it's good for the customer experience. Okay, that's the setback. You can consider it as automatically run during the absence of customer. Next one is the 4-season operation. That means you can shield the auto units running mode in different seasons, such as you can just use cooling in summer. That means all of the indoor units cannot be switched to heating to avoid the misoperation by some spoiled child, right? Or the air supply in transition season, just turn on the fan. Use the fan, no heating or no cooling in the transition season. Or in winter, lock the heating, cannot switch to cooling. Okay. However, you can also use the master indoor units to get this, but maybe sometimes people forget, right? You can also use the outer units to just lock the total system running mode to avoid some problem, misoperation. Okay, next one is the comparison with the other brand. Okay, friends, I think for this part, no need to discuss because we don't have too much time. We don't have too much time to talk about this part. But what I can tell you is GMV6 can beat the other brand absolutely. You can see every item, every part. The GMV6 the performance is better than the others. Okay, and okay, we just have a brief conclusion. Okay, first one, GMV6 is the EVI conversion, and it has the independent EVI expansion valve control, and the subcooling. Subcooling is plate heat exchanger can be 35 Celsius subcooling degree Celsius, and it has the HPAC new efficient module control, right? SRL control logic, and diversity mode. There is also new diversity mode, and for the capacity, output time is 75 seconds, just 75 seconds. It can reach to 100% output capacity. And for the communication network, that's the CAN protocol. CAN protocol. The inter-unit quantity that's bigger, and also you can increase lots of different parts, controller, gateway, and the other BMS. So the accessibility is better. And also the volume control. You can use the winding as a backup or preheating time, just 2 hours. Oil return. It has 6 oil pass. And oil drain control. There is a oil pump inside, right? For the PCB, compact design, electric box is also compact. And for the operating range is very wide, from -30, right? -30 to 55 Celsius. That's very wide range for most of the region over the world. Okay, for the other advantage, I almost introduced them, and I think no need to review all of them one by one. And okay, gentlemen, very happy and very honored that all of you joined this online live stream of GREY 2021 product promotion. I'm very glad that you guys can spare your time and join our training. Thank you. And in this presentation, maybe I didn't introduce all of our products for just one time. So if you have any request or the things you're curious about and want to know from us, you can email to your corresponding sales. And here is my personal email, and hope that you can get some useful and valuable information from this presentation. Okay, thank you guys. Do you have any problem else?
No more.
Okay, gentlemen, do you have the other problems for the GMV6, or if no? Okay, for this presentation, I already shared with your sales. You can contact your salesperson, sales manager for the copy. Okay, no worry.
Okay.
Okay, yes. The
Okay,
copy
thank you.
presentation I already sent to the sales. You can ask them to get And I already put all of the different series for different markets to one presentation. You can just choose and read by yourself. No needs. That's my pleasure. That's my pleasure. Thanks for your participation. Okay, thank you guys. So for today's training, we are finished. Okay, we are finished. Thanks for your
Thank you for
training.
yes,
And
yes. Thanks for your training.
have a good day. Okay, have a good day. Thank you guys. Bye bye.
Okay, bye bye.
Thank you.